Caroline Daniel is a partner at Brunswick. She's a real thought leader in the technology space, and for years she edited FT Weekend, and it puts her in a great position to be asking the question. So we'll give you a warm London welcome. The next voice you'll all hear is that of our next chair, Caroline Daniel. Thank you.
Hi everyone in the room. Hello everyone online. Delighted to be back at CogX. I think it's one of the best festivals I've ever been to, and in fact I was there yesterday and it was a great crowd and a great vibe. So I'm sorry I'm not there today in person. I'm here to do hopefully a great interview with Rob Glaser, who's my guest today. He is the founder of RealNetworks. For those who don't know RealNetworks, I've done some homework for you to save you some time. So he's had it's a 25-year-old business, which was a great specialist in digital media capabilities. And in fact, for those of you who are old enough in the room to remember something called Napster, RealNetworks both owned Napster for a long period of time and has recently sold Napster. So if you have any sort of questions about, you know, how Napster competed with Spotify and what happened with the great big story of the rise and fall of Napster and the success of Napster over the years, then please ask Rob. But we're actually here to talk about AI and particularly the ethics of AI. And Rob's got very involved with this with machine learning because of their facial recognition technology software platform called SAFR, S-A-F-R, for those who are writing this down. And so with that, I'd just like to introduce Rob Glaser and bring him, as it were, onto the stage from the delights of America. So Rob, lovely to have you here.
Good afternoon, everyone there in London, and good afternoon, Caroline, and thank you for having me today.
Great. So we're going to go jump right in onto the very challenging issue of facial recognition technologies. So we spoke yesterday about a great comparison you had around when cars arrived on the scene, and there was a need to develop sort of guidelines around seatbelts and the kind of rules of the road. And why do you think it matters around AI and particularly around facial recognition technologies that you need to have clear rules for the road?
So basically, if you look at the era we're in artificial intelligence today, we're in this era where there are not very clear rules as to what's going on. So you have, in very few parts of the world, do you have clear rules with regard to disclosure? Do you have very clear rules with regard to data transparency? Very few rules in terms of how algorithms have to disclose how they work, their bias or lack thereof. So it's kind of like being in a world where we have cars on the road, but we have no speed limits. We don't even have road signs a lot of the places, and so it's a lot of chaos can ensue. And imagine how dangerous cars would be if you had no speed limits, if you had no clear road signs, if you had no rules of the road, if you will. So we are huge advocates of governments having sensible policies that actually establish those rules of the road for all kinds of AI, including, of course, computer vision, like our Safer platform participates in. So we believe that in this next several years, it's about establishing the rules of the road, establishing the best commercial practices, educating end users and consumers so that we end up with AIs that are safe to drive, if you will.
So the idea of facial recognition technologies has obviously been probably one of the most controversial areas of the application of AI. There's probably a lot more coverage of concerns about facial recognition than many other areas. So just great to hear, just to set the scene for what does your software actually do and what kind of clients are currently using it?
Yeah, well, Safer is a general purpose computer vision platform, and it does have facial recognition as one of its capabilities. It has a range of different object detection, and it's used in a lot of different use cases. It's used in security and surveillance use cases. It's used in IDs for sort of digital ID, for instance, if you want to do remote banking and people want to verify that you are who you're supposed to be, computer vision can help with that. We've been used in physical access if you want to get into a building and have touchless access, particularly in this era of COVID, where you don't want to be putting your finger on a door or even using a grimy key card. Touchless access can be a very safe way to get in and out of physical spaces. So those are just a few of the use cases. And our Safer platform has some very, very unique capabilities. One is it's very small and very fast. So it can be embedded in all kinds of camera devices. We have a partnership, for instance, with Axis, one of the leading camera makers in the security business. And Safer is the first computer vision platform that can be, facial recognition platform, that can be embedded in the Axis cameras themselves. And then relative to today's conversation, we've worked extremely hard to have very low bias. And I'm sure we're going to talk a lot about bias in the moments ahead. But basically, when you look at any of these algorithms, they report out their accuracy. And that's, of course, very important. But what people are realizing increasingly is accuracy is inaccuracy, which is to say, if you look at accuracy against a different cohort, accuracy with black faces, accuracy with Asian faces, accuracy for women versus men, accuracy for children versus adults, you get very different data when you look at the performance of any of these algorithms and subsets. And it has a lot to do with how the algorithm has been developed and trained. And we worked extremely hard. We used a global data set that was unique to our system. So basically, we've been called out for praise by the National Institute of Science and Technology in the United States for having extremely low bias. And we think that that's an increasingly important consideration, particularly when you look at some of the social dynamics associated with trying to combat injustice in our society, which have come out, in the years since the horrible murder of George Floyd in the US and other phenomenon around the pandemic, especially. I think there's an increased sensitivity to making sure that the algorithms have low bias, making sure that there's transparency and understanding what the bias characteristics are, and having companies work really hard both to reduce bias in their systems and to be very transparent about the actual performance in the real world of these algorithms and when you measure them against different cohorts.
I was just asking a question about bias and transparency. So in terms of the transparency of algorithms, some companies have chosen to publish how effective, in terms of percentile, their algorithms are against different demographic groups. So for example, if it's sort of 95% effective against women, they might disclose that versus 96% effective with men and recognizing male faces. Do you think that level of transparency is going to be essential for trust in things like facial recognition technologies?
Yes, what we've done so far is we've used the analysis of independent third parties, like the U.S. National Institute of Science and Technology, but we'd love there to be a global standard, or at least a federal standard in the major countries, where you say, here's what you have to disclose. I sort of view my algorithm, my design. If you look at this box of food in the United States, and I'm not endorsing it, but it literally has a federally prescribed set of labels that have, and the federal rules for labels actually go to even the font size, where it has to say in very large letters how many calories it is. It has to say what the ingredients are. I think that kind of algorithmic transparency around bias would be great, and to actually have some independent validation. So if a company says that their algorithm is 97% accurate with women and 98.3% accurate with men, that there'd actually be some independent data set and an independent, something like Underwriters Labs or something that companies could go to validate that the algorithm does perform as they say. Now, of course, any of these slices and dices of an algorithm's lack of bias will have an element of subjectivity to them. Like if you look at Asian faces, do you count all Asian faces? Do you subcharacterize South Asian faces versus other parts of Asia? We can have that discussion, but at least a first order approximation of saying, hey, you've got 3 or 4 fundamental, phenotypes of the human species. You've got two genders, not discrediting non-binary people, but two main genders, let's say. And so you look at that sort of 3x2 matrix. It'd be useful to know how the algorithm performs against those sets. Now, with regard to kids and children, that's another vector in terms of age, and it's a much longer conversation, even whether systems, how they should be used for younger children, et cetera. But you could also imagine age as a vector. But it's not that hard to envision a situation where there'd be some basic disclosure rules that aren't as complicated as the food box. We aren't any more complicated than the food box. That tells us basically what we're dealing with in terms of algorithmic lack of bias, and at least starts the conversation or elevates the conversation of the importance of these.
In terms of, it'd be great I'd be very happy if you can have a facial recognition technology system which assess my age as being a lot younger. I think that would be an excellent intervention for your software. But I'd love to hear about some of the sort of differences you see as an executive whose software sells around the world into lots of different markets, and obviously attitudes to surveillance, so-called surveillance technologies are very different. You work in lots of different markets, and I just want to get a sense of how are these debates changing around the world. Obviously, Europe scene is very much in the lead on some of the kind of privacy concerns around facial recognition technologies. There was just an analysis this week by over 150 different privacy activists calling on the EU to make sure that these technologies are being sort of increasingly regulated, or in many cases, sometimes banned. It'd be great to kind of get your sense of the kind of global context that you're operating in, and whether you're seeing this as a debate in every single market, or if it's just sort of in Europe and perhaps a bit in America.
In the U.S. and Europe, the debates about privacy are very prevalent, which is a fundamentally good thing. The policies themselves are lagging, and the U.S. There are a few municipalities that have tried to have policies that in the state, United States, that we're resident in, Washington State, we came very close to getting a really good statewide privacy bill that we think would have moved the ball forward and would have created much greater disclosure, much greater transparency, some clear rules of the road. Unfortunately, for sort of local political reasons, it didn't get done. U.S. national law moves more slowly. You know, that's the whole melting pot of democracy theory, that you start things in the states, in the United States, and you bubble it up to the federal level, the experiments in democracy view. In Europe, just as Europe has taken the lead with GDPR, which has been a very positive thing fundamentally, there are pan-European efforts to move forward regulations and rules on privacy. And we're fundamentally very supportive of both the idea of doing that and most of the specific forms of that. So we feel, we see that there will be progress made. I think in this interim period, we think it's important for industry leaders to actually do voluntary things such as disclosure, to actually start to increase the understanding of within the culture that these technologies can be used well and appropriately. And on the flip side, if you certainly look at some of the word that's come out of certain parts of the world, for instance, what's going on with the Uyghurs in China, and the Chinese government's surveillance on that cohort of people, I think there are cases where the technologies aren't being used appropriately, and that's, I think, certainly something that we as a company feel strongly about, and we have emerging practices around ethical deployment of technology. But I think there are different sensitivities in different parts of the world. You know, we're not trying to make every country have exactly the same mores and ethics as the United States, but we are both trying to elevate the discussion everywhere in the world, and where we can nudge the policymakers along to have sensible policies and thoughtful policies that ultimately we think will make a difference.
When you talked about the idea, we talked the other day about the idea whether banning facial recognition technologies is a bit like trying to ban gravity or stop gravity from happening. Can you just sort of unpack that for us in terms of, is this now unleashed in the world and therefore possible to kind of regulate now that it's sort of being used in so many different markets already?
Yeah, well, there's a huge amount of the technology that's already been deployed. So if you actually say, as a few municipalities have, such as the city of San Francisco, that we want to stop the police from using facial recognition technology, you can certainly do that from a mechanical standpoint, but then you have so many different jurisdictions. If you stop the city police from doing it, but the Federal Bureau of Investigation is still doing it in the city, you haven't really achieved your objective, or you haven't achieved a very comprehensive version of that objective. Moreover, I think there's all kinds of use cases where it's very good to have facial recognition to help both catch criminals and to help victims, as well as to prevent innocent people from being falsely accused of crime. Sort of by analogy, DNA evidence. DNA evidence can be both condemning and exculpatory. And there are many, many examples. In fact, I know a good friend of mine is the chair of something called the Innocence Project, and one of the chief things they use to get people who have been wrongly accused of crimes out of jail is exculpatory DNA evidence. Similarly, you could imagine with all these body cams that are out there that are recording, reams and reams, thousands and thousands of hours of footage. If you have all this footage sitting on a server somewhere, and it's impossibly inefficient to go find stuff, and you want to exonerate somebody, and you literally can prove in the body cam footage that the person who was seen is not that person, because you can identify who the person is, and you do recognition against that person, and you can demonstrate that the person who was asserted to have been involved in a given crime location wasn't there. That's an example of where, if you actually use computer vision and facial recognition, you can actually go through evidence some cases much more efficiently. Otherwise, some cases literally where it would have been completely impractical to forensically scan everything out there, to find the needle in a haystack that would have been exculpatory for that person. So in my view, banning is the wrong way to go. Having clear rules is the right way to go. Sometimes those rules will include certain cases where you're not allowed to use the technology, but more often than not, I think the right policies will actually encourage people to use the technology responsibly for forensic uses, for instance. And in my judgment, that's what better policies will hopefully do. And by talking about these issues openly as a technologist, hopefully we won't have a conversation with the technologists who are afraid of regulation. We flip it around, but we actually do want good regulation.
So there was, again, a sort of big debate in Europe recently about Clearview AI. And one of the concerns there was how far they were building their facial recognition technology software on a broader database of faces that they found on the internet. So obviously the debate isn't just around the applications of it, it's actually about the original data sources. I wonder if you can comment on how you at your company approach that issue of the original data points, and how you make sure that you're doing that in as unbiased a way as possible in terms of having access to those kind of, suite of faces.
Well, to be fair on Clearview, all I know is the media reports in Clearview, and if the media reports are correct, Clearview violated many of the terms of service associated with the public posting of images on social media and the like, in order to build and then scrape a database, and that's a particular issue for them to deal with. The data sources that we use for our computer vision training of our algorithms were all not anonymous, non-PII based faces. They were tied to previous products that we and various partners of ours had in market, where it was consistent with the terms of service for us to use the data only for anonymous model training. And the fact that one of the reasons we have such low bias is the data set we used is global, based on software and services that were deployed in 6 continents across a wide variety of ethnicities and demographics. And so, one of the problems is most data sets that AIs have used have been based on a dominant language, a dominant culture. So, for instance, the Chinese facial recognition companies, they tend to be really good at Asian faces and not very good at Caucasian or African American faces. Similarly, a lot of the US-based companies that didn't use global data sets had a lot of bias because they used Caucasian data set primarily, and they had a very sparse amount of data for these other ethnicities. So that's a huge part of it. A second thing you have to do is you have to have people who are very good at training models. One of the things about AI is the model is not the reality. So you actually need to have a constant feedback loop where you're calibrating the data that your model is using against assessment. The other thing to say is that if you're trying to assess whether 2 faces are the same, you're actually assessing whether a person thinks they're the same. So the canonical use case is identical twins. If you have identical twins where you or I couldn't tell them apart, neither could the algorithm, right? Because the algorithm is relying on people's assessment whether those 2 people are the same person or different people. So, and in fact, we know that identical twins are actually 2 different people. They just look incredibly similar to each other. So, I would say that any algorithm will be imperfect, just for the identical twin case alone, if nothing else. But I do think that if you work really hard at it, you can get that bias down super low. And to use a language, there's an excellent book called The Alignment Problem that talks about this by a gentleman named Brian Christian. And the more you can align your data with the underlying physical reality, the better. But you just have to recognize that your alignment is going to be imperfect. It's just you want to get it as close as possible.
One thing that just struck me as interesting about the AI debate sometimes is that everyone's very obsessed by AI and bias, but actually I think not enough attention is being paid to the sort of bias of human beings. I'm in the middle of reading The Undoing Project, which is a fantastic book, by the way, by Michael Lewis, which really explores, as a sort of psychologist, all the errors and mistakes that human beings tend to make about as experts, including showing a similar sort of cancer, pictures of a tumor to the doctors and then showing them the same one again and asking how they'd analysed what the problem was. And they, even when they were looking at the same data a few minutes later, they made a different answer to what they thought the diagnosis was. So as an AI sort of person, you know, in the cutting edge AI, how far do you think that the issues of actually how far AI can help resolve those issues of bias perhaps isn't being talked about enough? I'll give you one example at the FT. The FT created this amazing bot which was looking at the amount of coverage in news articles and using AI over how many people were female spokespeople versus male spokespeople to make sure that the journalists at the FT could be more aware that they should be citing more female spokespeople. There are lots of opportunities of using AI to counter bias, rather than just the sort of apocalyptic concerns around the application, the misuse of these technologies. I wonder if you can sort of have a perspective on that, around the opportunities of AI to resolve bias.
Yeah, I think that's a great point. I mean, if you go back, and these are examples that are in that book, the alignment problem I described. You know, when I was a kid, I remember there used to be in the box of crayons I had, there was a crayon called Flesh, and of course the flesh, it looked like my flesh. Not the flesh of an African American, dark-skinned Black person or dark-skinned South Asian person. So that even in that case, we look at among the first toys we give our children, there's bias. Another example that's from my own personal example that's in this book, The Alignment Problem, talked about the Shirley card, which I'm dimly aware of. Shirley card was the card that analog cameras used to calibrate their colors, make sure that their color palette was mapping pretty well onto the natural image of a person. And it was literally based on a woman named Shirley who worked for Kodak. And of course, Shirley was a Caucasian. And all through from the origination of film up through the 1970s, all of the Shirleys were Caucasian. So basically the cameras were being calibrated for Caucasians, and they weren't being calibrated for darker skin tones, leading to the inevitable fact that those images were not captured as clearly. So what that does is it creates a situation that even if you're trying to make your algorithm as good as possible and you're training, your data set is going to include images that are calibrated for accuracy of certain skin tones and are much more inaccurate in other skin tones. So for that kind of case, once you know that, you could actually do an algorithmic counter example for that. The problem is when you try to use algorithms to counteract underlying bias, you create a significant risk of problems in other directions, sort of unintended consequences, because it turns out that you have other risks. There's a very famous example of this, was a system that was used to determine parole in the United States called Compass. And the Compass system was demonstrated that it was as a predictor of whether people would commit new crimes if you let them out. It was calibrated to be equally accurate across different ethnic groups. So in the data set that I was reading about 60% of the time, it gave you the right outcome, whether the prisoner was African American or Caucasian. The problem is, in the other 40% of the time, the actual way it misperformed was different. So 40% of the time, it actually prevented people from being released who ended up having a super low rate of recidivism if they were African American. And the 40% of the time it misperformed with Caucasians, most of the time it was in the direction of letting out people who were then likely to recommit crimes in the future. So it's actually the case that even if you try to have the right balance for how you make something based on one objective, which is what's the rate of recidivism, you actually then have secondary effects, which is if you have a different set of ethnic groups that you're applying it against, in one case, it locks more people up than should be locked up. In another case, it lets more people out than should be let out within the area. So you have a huge set of problems that ultimately go back to societal inequities and societal biases that it's very, very hard for algorithms to counteract. So I think my ambition would be a little less than what you're saying, which is let's have transparency on where there are those inequities so we can have societal progress against those inequities rather than expecting the algorithms to do it for us.
So I have a question from someone in the audience. I don't know if it's online, but asking you about facial recognition and everyone wearing masks these days. And can you just sort of unpack how easy is it now for AI to actually still perceive who the people are even when they're covering in a mask?
So we had good success with our mask detection algorithms, and we put them to use primarily for people who wanted to do mask enforcement. We have a free product we put out called Mask Check that was been used in schools around the United States, and some small businesses used it as well. And that's where, fortunately, in the U.S., we're getting out of the phase where that technology is necessary. We demonstrated that we could also use that technology with our secure access facial recognition to have very significant improvement in quality. So we got to where, if our algorithms are normally like 99% accurate for faces, and you can then describe it in terms of false negative or false positive. With masks, we got it up to 95%. So we made significant progress on being able to do facial recognition for other attributes on the face, even when people were wearing a mask over the bottom half of their face. But of course, if you only have the bottom half of the data, it's still the case that you're likely to have lower accuracy. But we were able to get the accuracy up significantly. But that was not a major commercial deployment. The main way we used mask detection was simply straightforwardly for places that wanted to encourage people to wear a mask properly, and we got really good. Our algorithms got really good at mask versus not mask, mask that was covering the mouth but not the nose, mask that was not really the covering the full scope where it was necessary. So we tended to, in that case, see the best success not for facial recognition with mask, but for just mask detection in its own right. So I see we've lost Caroline. Let me do one or two things while we're waiting to get Caroline back or not. I know we've had some audio problems on her end. One of the questions that somebody asked, which I'll read out, was companies are increasingly dependent on AI for hate speech detection, but there's research that shows that there are clear bias even there. How should companies move forward to reduce these biases? Well, clearly one of the big problems we've seen in the United States over the last couple of years has been, around the world especially, but especially in the United States, I'm sense to it, has been the role of social media with regard to propagated speech. And I think in the short term, one of the best things we can do is use AI and natural language processing to flag potential violations of hate speech or threats or things that don't belong on live social media. But I would not say that should obviate the need for humans to actually make secondary judgments on those, because clearly the classic case study is you can't yell fire in a crowded theater, but you could say, hey, look across the street at that fire. And you're not yelling fire in a crowded theater, you're just pointing out the fact that there's a fire across the street. Or you could say, hey, tonight it's kind of cold, shall we put the fireplace on? So if you're keying off the word fire, you could have it be completely benign, or you could have it be, if you're in a crowded movie theater and use that same word, that's not protected speech if you're inciting a riot. Similarly, if you want to have a conversation about whether the U.S. presidential election was biased or not, or was a legitimate election or not, or you want to have a conversation on whether the COVID-19 came out of a lab in China or came out of animals, you ought to be able to have that discussion, in my view, without the speech itself being considered the problem. Some of it has to do with the context of what you're doing. I mean, if you say, if you say fire in a crowded theater, if you say, hey, we should kill people, that's wrong. But that's in the context, the semantic context of what you're saying, not simply the words in isolation. So I think it's an extremely hard human problem to assess the impact of giving freedom of speech, and the notion that you could give it over to AI to make any final determinations, I think would be a dangerous overuse of AI.
Great. So I think we're down to the very last question, which is just in thinking about AI and the sort of next 10 years, what keeps you awake at night in terms of your biggest concern about the application and use of facial recognition technologies as they become more and more prevalent?
Well, I would say the biggest thing that keeps me awake at night is the growing tribalism of society in the context of the interplay among social media, certain increases in inequality. And I think, so I am more left awake at night, not by AI per se, but by the underlying social dynamics that we in the world, including those of us who create AI, are trying to address. I'm not personally one of these believers, people who thinks that AI is going to take over the world. I'm not a massive proponent of what's called artificial and general intelligence, or AI. I think it's super interesting research, but I don't think we're going to, like, give over general, sort of control of our airplanes or even our cars to AIs in the next 5 to 10 years. But I do think there's a lot of social inequality that is going on. There's an increased level of tribalism in the world, and I think the notion of using any technology to address those issues by itself is putting blinders on. And I think the biggest things I'm worried about are the underlying societal trends. We've just, we're going through, and in some cases are making progress against going through this massive, once in 80 years, global mass trauma event, the pandemic. And so coming out of that, I think there's opportunities for the world to get worse, and there's opportunities for the world to get better. And if you're an optimist, you'd say, hey, science did an amazing job. We got these vaccines from nowhere to being deployed in hundreds of millions of people successfully, probably close to 1 billion at this point, maybe over 1 billion people that have been all the way through the vaccination process. So we have reason to think that science, that the case was not narrowly AI, can be helpful. But I think that I'm not a believer that the biggest social problems we're going to have in the next 5 to 10 years will be societal problems in general, will be AI based. But I think AI can help us deal with them, but only in a very secondary way.
Great. I really appreciate your time. Sorry for the technology, but it is a technology conference. So if AI can fix my tech next time, that would be awesome. And thank you to everyone in the room who was listening, and to everyone online who was listening. Rob, thank you very much for your time. Appreciate it.
Thank you, Caroline. Great seeing you. And it's a great reminder that we live in an analog world as well as a digital world.